The oceans. They are always on the move. Together, the ocean basins are like a big interconnected highway that transports nutrients, carbon, and heat around the world. This mesmerizing data visualization of ocean currents was created using a model called Estimating the Circulation and Climate of the Ocean, or ECCO for short. It's built using real-world data from satellites, buoys, and all kinds of other measurements. All of this movement starts with physics. Because the Earth is spinning, the water feels something called the Coriolis effect. This pushes some of the strongest currents, like the Gulf Stream and the East Australian Current, against the east side of the continents. Because these currents wind up on the west side of the ocean basins they sit in, scientists call them western boundary currents. In this visualization, the currents closer to the surface are white, and the deeper currents are blue, almost like you're seeing those deep currents through the top layer of water. But what's causing all this motion? And what makes some water rise and some water sink? Let's take a look. Here we can see the Pacific Ocean's strongest current, the Kuroshio. It begins in the warm tropical Philippine Sea and then flows north past Taiwan. After it reaches Japan, it turns east and heads across the Pacific Ocean, spinning off huge eddies where it turns right. The Kuroshio carries over 200 times more water than the world's largest river, the Amazon. This visualization makes it easy to see how the ocean moves water across the planet. But what's hard to see are the places where the water moves up or down. This is called upwelling or downwelling. When upwelling brings cold, deep nutrients into the sunlight near the surface, it creates a feeding ground for all sorts of ocean life. Nutrients, carried in part by the Kuroshio current, help feed the fisheries in Japan and create an important economic zone for the country. Another major western boundary current is the Agulhas current, which carries water down the east coast of Africa to its southern tip, called Cape Agulhas. There, the current makes a sharp turn to the east, but sometimes it pinches off giant eddies called Agulhas rings, which drift west into the Atlantic. These circular currents carry salt and heat into the Atlantic and form an important part of the overturning circulation, also known as the global ocean conveyor belt. This so-called conveyor belt is a system of currents that carries heat northward across the equator and into the North Atlantic. It plays a big role in the climates of North America, Europe, and Africa. Without it, winters in Europe would be much colder and droughts in Africa more severe. But the oceans do more than just move heat around. In some places, they absorb heat from the sun, and in others, they release it back to the air. We can see that in the Gulf Stream. Yet another part of the ocean's conveyor belt, the Gulf Stream starts in the tropics, where the water is very warm. As it drags warm water up the east coast of North America, it acts like a heater for the atmosphere. By the time this water has wandered across the Atlantic and wrapped around Europe, Iceland, and Greenland, it's gotten so cold that it sinks deep into the North Atlantic Ocean. But temperature isn't the only thing that can make water sink. So can salt. Salinity, or the amount of salt in the water, can make it heavy. The saltier and colder water is, the heavier it gets. As it gets warm and fresh, water gets lighter. Changes in the heaviness or density of ocean water are what keep the ocean's conveyor belt turning. The streaks you see near the surface show how water is moving from one place to another, but if you look closely, you can see that deep down, water is moving in a different direction, sometimes even the opposite direction, like it does far below the Gulf Stream. This cold, deep water headed south beneath the Gulf Stream is another part of that same ocean conveyor belt that keeps Europe warm. Some of that warm Gulf Stream water that heads north at the surface eventually winds up there, moving south again after losing so much heat to the atmosphere. Eventually, this cold, deep water will spread around the globe, and slowly rise toward the surface. There, it will warm up in the sun and get ready to start the trip all over again.